blank, because even if you have absolutely zero idea what to do, take a derivative somewhere. Put the units you know that are supposed to be there somewhere. You would not believe where you get points on a test like this. And so we're going to go through that so you kind of see. Y'all smile. It's okay. I promise it's okay. Robert Jenkins. All right, this will take the whole time, so I'm going to go fast. If you need me to slow down, tell me to slow down. If you've got questions, tell me to stop and ask them. We'll try not to get too caught up, but I hope that you will see by the end of it that you know you have all the resources you need. You know how to do it. It's just pulling it all together, and it gets kind of hard. All right. Number one, grass clippings. Make sure you read the question in its entirety. So grass clippings are placed in a bin where they decompose. And by the way, if you want anything scored or don't want anything scored, make sure you scratch it out. Otherwise, they score everything. But I always tell students, even if you write stuff up here, come down where they're going to score and rewrite it if you want it scored at all. Because, again, you get little points for almost things that seem like almost nothing. Okay. But they're kind of old. Make sure they work. It might take a while to start them.
It would have to be
I don't use red pens too much. That one doesn't work either. Shut up. Let me. Put them on like a stack of paper instead of just one paper, and it kind of softens up the. I know they're old, but I fished them out. I forgot to get some. Fast, Robert.
Oh, it's coming along. It's back on.
Put it on my stack. I know. I'm sorry. Governing, or I got colored pencils. That's the next best thing I got. Sorry. It's not. Okay, I'm sorry. I tried. All right. So we've got this equation, right? For 0 to 30, the amount of grass clippings remaining in the bin is modeled by. So it's important to wrap your brain around what it is we're looking at. This is a terrible equation, but you have a calculator. These are set up to where if you tried to do them by hand, you would either not be successful or you would be there all day long. So do not get caught up. If it's a calculator, it's a calculator for a reason. Let the calculator do the work for you, okay? All right. A of t is measured in pounds, t is measured in days. I underlined that because I did not want to forget that. Find the arbitrary change of A of t over the open interval and then indicate the units of measure. This is a straight up Algebra 2 or pre-cal problem. So AROC is nothing more than what? Slope. So you need A of 0 and you need A of 30. Because this is a calculator problem, you don't have to show work finding these. Put this equation in your calculator, go to your table. What is A of 30? What is A of 0, right? You can even, well, I find it better too. I did this. 6.687 pounds. I am OCD on a test like this at writing the actual units on here. And 0.7829 pounds. And now all I have to do is plug in that AROC formula, right? 0.7829 minus, make sure you're taking out at least 3 decimal places. It is not advised for you if you've got a calculator to round like I did here. It's better to keep them stored in your calculator and put them in there. But if you do, you should still come back to the right thing, which is I always do approximately also. I read a horror story about a grader that was really mean one year that went through and said the kids were writing equal signs and it wasn't actually equal because it was a rounded thing. So I always put approximately negative 0.1968, and this is a rate. This is rate of change, pounds per day. So where do your points come in? Yes, you could leave it just like this and you could be okay, because as long as you could plug it into a scientific calculator, a basic 4-function scientific calculator, you can leave it just like that and you don't have to simplify. So either one of these. But the key here, the kicker, was the units. And so this one was only 1 point, but you had to have the answer and the units to get your point. And sometimes you'll get the units, you'll get points just for the units. One of these questions, I think you do get points just for the units. Questions, everybody okay? All right. Y'all try to time in that one. It's been 15 minutes on a question. Just correct it in a different color pen, like write it. If you don't. I would, so if you go back and look, you know what you need to do, what you need to put. All right, part B. Find the value of a prime of 15. Remember, this is a calculator problem. So when they say find this, I've already got that equation in my calculator, right? That equation for A of t. That's in my Y1 already. So it says use correct units and interpret the meaning in context of the problem. Believe it or not, this is a 2-point question, okay? 1 point for the derivative, 1 point for the interpretation. The derivative here, which is straight in your calculator, this is inderiv, right? Inderiv Y1 at 15, you should get approximately, let me make sure my matches theirs. Yep. 0.163. Actually, it's negative, isn't it? Is it negative? Negative, yeah, math, and then down to inderiv. Negative 0.163, which gets you 1 point, even if you didn't do, actually, no, you got to get the, no, you don't. Just that, just the derivative at that point gives you a point. So here's some point. The other point comes in, and I did go ahead and put on mine. I told you, yep, what's wrong? All right, you got Y1 in your A of t is in Y1? All right, so now hit vars, go over, and then comma x, comma. Now, the next part's the hardest part, in my opinion, of this part, because they ask you to interpret here, okay? And when they say interpret, they're saying, what does this mean? So this means, and here's what you have to include in this. At the specific time, so at 15 days, you have to say that, or you have to say when t equals 15, or when time is 15, or on the 15th day exactly, but that has to be in there, because remember, we're instantaneous rate of change, and they want to make sure you understand that. So I put, on day 15, the amount of grass clippings is decreasing at a rate of 0.1636 pounds per day. 1 point for your derivative, 1 point for your answer. So you have to say at the specific time, and then you have to give the rate correctly with the unit. So on the 15th day exactly, or at t equals 15, or so, but make sure you have all of that before you give yourself your points. Everybody okay? Yeah. Because you're looking at a rate. So because it's a rate, that gives you your average rate of change, right? So that's per something. So it's pounds per day. If you were just looking at okay, so pounds would be if you plug into this equation, that's pounds. If you plug into this equation, that's pounds per day. Because this is a derivative and this is the function. You see what I'm saying? All right, part C. Find the time t, not far, for which the amount of grass clippings in the bin is equal to the average amount of grass clippings. I underlined that because I automatically saw that average amount. Average amount of grass clippings in the bin over the interval 0 to 30. Okay, so I tackled that first, right? What's the average value of the function? How do you find average value? The what? That's average rate of change. Average value, remember this one? So your average value there is going to be 1 over, I've got 30 minus 0. Anytime you see average value of a function, you're using that average value formula with the integrals, okay? I'm going from 0 to 30, and I always rewrite the equation. They say that if you've already defined A of t, then you could just write A of t right here. I'm always hesitant to do that. I always rewrite the equation. And so I put 6.687. But you do what you want to do. You'll still get your points. Just don't forget your DT on it no matter what you put in there. Again, this is a calculator problem. I don't have to do anything else with this other than tell them what the answer is. I have to show the setup and then tell them the answer. So the answer, if you plug this in, is approximately, I got 2.7526 pounds. Is that what y'all got? Oh, nobody did this right.
All right, so that's. Oh.
I haven't finished yet. I haven't finished answering the question yet. What are these? All right, so I haven't answered the question because if you go back, I was sitting here looking at my work going, what am I, but I know what I did now. I work this with y'all, by the way, whenever y'all do it. Some of them same time frame, so sometimes my brain is kind of. But it asked me, find the time t for which the amount of grass clippings in the bin is equal to the amount of grass clippings in the bin over the interval. So this is the average value of A of t. That is in pounds, right? Because A of t is in pounds. So that's its average value. When does A of t equal that? So when does 6.687, do not forget this is a calculator. When does that equal this? And so I pull out my calculator. You can do this a bunch of different ways. Since this is already in Y1, right? We've been referencing that in Y1 this entire problem. I could put this in Y2 and find the intersection of the two lines. I could make it equal 0 and find the 0. I find it easier if I've already been working with this in Y1 just to come down to Y2, enter that in, and do second trace intersect, because then it's just an enter, and I'm done. All right, so if this is already in your Y1, you put this in Y2 to find out where it equals that. Then hit graph and go Y. Yeah.
You do not want to know what I just did.
No, I don't. So put it in Y2. You got it? And now go second trace for intersect. Just kind of scroll over close to it, and then you can just hit enter, and it'll pop up with the intersect. So I got t is approximately 12.415 days. 1 point for the integral setup. For this, you got a point, and then for the answer, you got a point. So that was a 2-pointer. So far, you've had a 1 point, a 2 point, and a 2 point. The last one is the heavy lifter. The last part is worth 4 points. Don't think about it missing points, thinking about how many points you earned. Yeah.
It feels like a really hard one.
Well, let me see. B. They just have you having a point for the answer itself. So if you got 0.16, they have you getting a point for that, and they don't have units indicated on here. So I would say you get that point this time. But be careful in the future on that, because you might have. It depends on your. I would say that would depend on your reader. I would probably give you that one since they didn't. It seems like as we get closer to like now, like this is 2014, as we move forward, they get pickier and pickier about stuff. But on this one, they took that. All right. Use for t is greater than 0, L of t, the linear. What does linear approximation mean? Somebody please tell me you remember. It's a line. What kind of line? It's the tangent line. All they are asking you to do here is find the tan line at 30. That's it. Okay. So the tan line at 30, and then they want you to set it equal to 0.5, not plug in 0.5. But let's do the tan line first. But let's call it L of t when we find it. So if we need a line, we need a slope and a point, right? We're using this A equation again. My slope is going to come from here. My point is going to come from here. Again, I'm using my calculator. I got negative 0.05598 because I used my calculator here. I'm off time track already. I'm supposed to be done now. It's okay. 0.7829 is what I got here. No, but if I give 15 minutes a problem, I'm a lot more structured when we get to the review than when we get to the other stuff. Okay, so this I got from the table, right? Y equals, I went to the table on my calculator and I input 30. This one I got from inderiv. I've still got that same function plugged in my Y1. I have not changed it. Okay? All right, so how do I write the equation of a line? Well, I do Y minus Y1 equals slope times, but it's not X, it's T, right? Minus, and I did mess up on that. I put X on mine all the way through until I got to the end. I was trying to erase and put, I would say yes. They get kind of nitpicky about stuff sometimes. Okay, so, but they ask you for L of T, so what I did was I said L of T equals because I knew they probably would give me a point for the equation itself, and even if I couldn't do anything else. So I went ahead, they like it solved for Y, not necessarily distributed out, they like it solved for Y or whatever it is. So there's your L of T. You actually, for this one, got 2 points. If you knew that L of T was the tan line, if you knew they were asking you for the tan line, that was an easy 2 points to get. If you didn't realize linearization and tan line were the same thing, how to get the tan line? Slope at the point, which is your derivative, and then the point itself in the original equation. It's Y, yep, slope times X minus X. The negative 0.055. Oh, I haven't gotten there yet. I haven't finished the problem. Remember, this is a 4-pointer, but 2 of my points, half my points came just in writing the tan line. And then if you continue reading, it says, predict the time at which there will be 0.5 pounds of grass remaining. Well, T is time, so I'm not plugging in for T, so I must be setting that equal. Again, if this equals 1/2, this is a calculator problem, and so I didn't, oh no. But you set L of T equal to 0.5, you set your equation, you get a point for that.
It wasn't actually L of T, but I thought it was.
Your L of T, though? Is it what you called L of T?
I didn't say it was L of T, I just wrote an equation.
If you'd have said L of T and you set that equal to 1/2, you'd have gotten a point. That's what I'm saying. The craziest things you get points for. If somewhere on your paper you do this, you got a point. Even if I didn't have any clue what L of T was, but I knew what they were asking me to do was set it equal to 1/2, I just got a point. That's why I said write something. Read the problem, write something, anything. And then if you go through and solve this, you'll find, and again, this is a calculator. I did 1/2 minus that divided by that plus 30. I did it all in at one time on my calculator, and I got approximately 35. Remember, I want at least 3 decimal places. I can go more, but do not go less, or you will lose that answer point there. Days. There's your last point. 4 points on that one. All right. 5 minutes behind. Yeah.
I didn't do that, but I got close there.
Until you find it.
And I got 36.
Because it's not out 3 decimal places.
Oh, so it had to be.
They have, yeah, it's got to be at least that many out, especially if you've got a calculator. They'll make it. You could, but they did. That's why they do the breakdown with the calculus. Yeah. All right, let's do the revolution. When you put it all together, you start feeling dumb, but you'll start getting into the groove of everything. All right, let R be the region. So I've got this graph. I wrote all over mine to the point where I was confusing myself. So I've got this funky graph. I hope y'all at least got a few points on this one. Y'all, come on. You just did it.
No,
At least a few. A was a washer. A was a washer. A was a washer.
Oh, wait. It didn't say that. It said the volume was.
Find the volume of R. Find the volume of the solid generated when R is rotated about the horizontal line. Y equals -2. Where is -2? -2 is down here. So I'm taking this and I'm rotating it around this line. So whole radius as opposed to whole radius. When I saw rotated around, I put that -2 and I immediately put whole because I knew. It's on my paper. No. But part A is 4 points. Remember, everyone's 9 points. You got almost half your points in part A here. All right. So here's my thought process, and I'll show you what I did, and then I'll tell you where you get your points from. All right. So the first thing I did was I said, okay, I know I need the radius of the whole thing. What's the radius of the whole thing? 6, right? It's easy to see if you draw it on there. If you don't draw it on there, it's harder to see. The radius of the whole, well, this space is the function, right? Plus 2. That's exactly right. So 2 plus, you can. So if you did +6, same, that's fine. Or, no. Remember, you're doing it the way I taught you. Wrong, Robert. Don't do that. Oh! You did it the way I told it wrong the first time. Oh my gosh, this is a disaster. Okay. You've got to do the areas first and then subtract them. All right, so here comes 2 of your points if you can set up the integrand. The integrand set up, even if you don't get the right answer, just the integrand set up gives you 2 whole points. So what is that integrand? I knew I was going to need this point. I found that on my calculator before I started. 2.34 was that point. All right, so the volume is pi times the integral. I do the area. You must have got this one because you're smiling. Okay, 36 minus. You can leave it as 6 squared. They are not picky about that kind of stuff. It could be 6 squared minus x to the 4th minus 2.3 x cubed plus 6 squared dx. Okay, have to do dx. Oh my gosh, please do it. You have to do the dx. If you simplified this any, if you didn't simplify it, as long as when you simplified it, that minus distributes if you do it that way. You could have even on here put f of x squared, and that would work. I don't ever like doing that, but oh, you do have to put the bounds. I'm sorry, from 0 to 2.3.
It said 0 for me.
Oh, because you're just giving you scientific notation. It's 0. I would put it 0 whenever it does that. When your calculator does that, put 0. Okay, yeah. So here's your 2 points, right? For that integrand set up correctly. Is everybody okay? Go ahead, but no from now on. Yeah. Okay. What was I going to say? What else was I going to say? Integrand. Okay. Oh, so then, actually, the integrand, you get what's inside what follows the integral sign. You get a point for this, then you get a point for the bounds.
Oh, so if I get
1 point, 2 points. So the bounds give you a point. That's why I said always write something. Okay. You got a point for the integrand, a point for the bounds, and then you got a point for the answer. The answer being, I did 31.4706 pi. If you wrote it, they did it as 98.868. Either way is fine, but you get a point there. So 4 points. How many did y'all get on the 4-pointer? 3, 0. Oh, that'll be okay. 4.
If I use that and I get everything else right.
That's fine. That's fine. 3 places is sufficient.
If I use that and I get everything else. I didn't get that.
Not the answer point you want. The answer's 1. So integrand, limits, answer. Oh no, integrand's 2 points. I'm sorry. Integrand is 2 points. You got 2 points in there. Look at you. Because any rotation is pi r squared. If it ever says revolution, rotation, it's pi r squared. All right, moving on quickly because I got 4 minutes to get through the rest of this one. So part B asked you for, and this is typical, y'all, if you've got a revolution problem, and you probably will, there are a few years when they are not, but if it's a revolution problem, you've probably got a cross-section in there, you probably also have an area part in there. And that way they test you on all those different things. So sucky as it is, these are the brutal problems. All right, so region R is the base of a solid, and it says that the cross-section's perpendicular to that is an isosceles right triangle. Well, the nice thing about an isosceles right triangle is that the 2 legs are the same, right? I don't have to do any calculations there. I just have to find that length. So I'm back on here, and this is where I just kept writing over my paper. I have to write it or I don't see it. This is the leg of my isosceles triangle. That's right. Yep. So I pulled it off to the side. I did a triangle off to the side. So this cross section is 4 minus that whole function, right? Which was x to the 4th, right? What was it? I lost my place here. X to the 4th. There you go.
That's what R is?
That's my R. That's my height of my triangle, which the 4's end up canceling out, so really it's negative x to the 4th plus 2.3x cubed. And so this side is the same as this. So the area is 1/2 negative x to the 4th plus 2.3x cubed. And I just did it squared because it's 1/2 base times height. The base and height are the same, so I did it squared. So to find volume, I integrate area. I'm going on the same bounds that I went before, right? From 0 to 2.3, I don't need the pi because I'm not in circles now. I'm not revolving. I'm just these triangles. And so I just do this 1/2 negative x to the 4th plus 2.3x cubed. dx. Yes, perfect. That's perfectly fine. Because it's 4 minus on this graph, it's going to be 4 minus this. It's a calculator problem. All I have to do is show the setup of the integrand. I got, let me make sure mine matches. Yep. 3.574 is what I got.
Really messing up.
You get 2 points for the integrand here. You get 1 point for the answer.
Wait, what do you get points for again?
2 points for the integrand, 1 point for the answer. That was a 3-pointer. So I put this as y1, and then I squared it so I didn't mess up on any signs or anything like that. And then I just divided by 2 in the end. For this one, you had to get, it's just 2 points for the entire thing. Okay, part C. Part C was probably the easiest one on here, but if you read it, you probably went, well, heck, I don't know. But if you thought about it, it was definitely the easiest. I read it and went, oh gosh, I don't know. And then I went, wait. And I went back and reread it a second time. It says equal areas. Area under the curve is just top minus bottom. And I literally, if y'all don't believe me, I wrote it on here. I circled area and wrote top minus bottom because I went, I was sitting here racking my brain going, how am I going to divide this up into 2 different integrals and this and that and the other? But you didn't have to because I mean, you have to do integrals, but if you think about it, it's not, there's no shape, there's nothing like that. It's just top minus bottom. So vertical line x equals k divides this region, right? So I've got some random k. So I came over here and I said, okay, if that's k, because I'm visual, I have to see it. If that's k, then what's the area from 0 to k? Well, that's from 0 to k of top. What's the top? Minus the bottom. What's the bottom? That function. So again, if you could have put f of x, it doesn't matter if you put f of x, or if you put, I wrote the function out because I'm extra. You can put the simplified one. You can, because yes, you've already done it in another part of the problem. Well, what does that equal? That equals from k to what? To 2.3 of the exact same thing. Oh, look at me. Yes, that's the answer. This was a 2-pointer. They said, and we'll interpret this however, I don't know, 1 point for the area of one region. So if you figured out, I guess, that this was the area, if you have that somewhere on there, 4 minus f of x, then that would give you 1 point. And then the other point for the equation that sets the median. How many points out of 9 did y'all get on that one? Better to shut up. Yes, ma'am. That's awesome. 2 points. 1 for the area. If you had this somewhere on there, the area of one region, that was a point. And then another point for the equation set up like this. The equation was, it said write up but do not solve. Yeah. All right. I anticipated you having the most trouble with number 1, and then they kind of went downhill from there. I hope this one was a little bit easier for you. The function f is defined on the closed interval from -5 to 4. The graph f, y'all, if you will, at the top of each paper, just somewhere like in the top right-hand corner or something, as several of you are doing, just put how many points you got out of 9 for that one, because that way we can go back and add them up and look at what you're doing. Okay. It's okay. It's okay. Remember, 50% is good. All right. But we're not, I know, but we're getting there. We're getting there. Just calm down. Okay. The function f is defined on the closed interval, blah, 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 the graph of f, and then it gives me this equation, g of x. I like it when they give me an equation like this. I have told you before, and I did it again, I always, if I have something like this, I start out by saying, what am I looking at on my graph? Because it says the graph is f. Well, so it's the derivative. That's right. I write that on my paper so I do not forget. You will forget if you don't write it down. I write it down up here by the graph. I literally wrote it at the start of my problem down at the bottom. I will forget if I don't write it. I write it, so I don't forget. Okay, what is the opposite of integrating? This is how I think about it. It's really a fundamental theorem problem, but derivative. So if I think about taking the derivative of both sides to cancel that out, well, the derivative of g is that. Don't ever write that on here, because they'll think you're just idiot, because that's not proper math, because this is actually a fundamental problem, but that's how I remember it. That's what I think. All right, so I'm looking at the graph of the derivative when I'm talking about in terms of g, right? So the very first one, which is part A, which I think was probably worth 1 point. Yeah. 1 point asked me for g of 3, and they gave me an equation for g, so I'm just going to plug in from -3 to 3 of f of t dt. If that's the graph of f, then I'm talking about geometric shapes and areas. So I went through, because you don't have to show it all down here, but I went through up here and I looked for -3, 3, and I found the area of each of those little triangles. Yeah, you can do that, because I'm just extra. We know that already. Actually, what I did first was I went from 0 to 3 instead of -3 to 3 and went, that's not right. And so then I had to go back and find it. Okay, so, but anyway, what you should get whenever you do that is, or what I got, make sure I match. It should be 9. It's 9. 6 plus 4 minus 1 because that's under. Remember, I'm finding an integral. Integrals can be negative. If they said what's the area, I would make it positive, but they said evaluate here, so I'm doing the integral. So this is 9. 1 point simply for the answer. That's it. Because I'm looking at the integral of f. This is the graph of f, so how do I find the integral? That's area under the curve. Then we get to the good stuff. Part B was a bit of a humdinger you had to think about. Do what? I know, it's hard. It's hard. All right, on what open intervals between -5 and 4 is the graph of G both increasing and concave down? So here's where I thought, because I'm going to assume y'all struggled with this a little bit. This is always a struggle. I thought, okay, they're asking me what G is doing. So I need to look at the derivative of G, right? And then they're talking about concavity, so I'm also going to have to look at the second derivative of G. Y'all following me there? All right. G, the derivative of G is F, right? Y'all follow me? So if I want to know where the derivative is 0, I'm going to look at where F is 0, because they're the same thing. So that's how I came up with the points, my kind of test points here, between -5 and, what was it? 4. All right, so where all is it 0? At -3 and at 2. Okay. Well, what is the graph doing? Well, the graph is above the x-axis, and below the x-axis. Okay there? Then I need to look at the second derivative for concavity. Well, the second derivative of G is the first derivative of F. Are y'all following me on that? So the first derivative of F, I'm looking at slopes now on my graph, right? These are the zeros. So now I'm going to look at the maxes or mins, or where it stops increasing, where the slope changes, is what I'm looking at here, where the slope changes. So on my graph up top, between -5 and 4, where is the slope changing? Well, it looks like it changes at -3. Looks like it changes at 0, which is going to come kind of between here. And then it's the same all the time, right? So this is a negative slope, concave down. This is a positive slope, concave up. This is a negative slope, concave down. So now I can answer the question that they're asking me. They're saying, where is it both increasing and concave down? Well, and there you go, this little space right here. So -5 to -3 and 0 to 2, but you have to say why, because it says give a reason for your answer. And I literally simply said that it is increasing, and I'm on shorthand because we're running short on time. You'd want to spell this out on there. And concave down on F. Did they ask me about F? No, G. On G, because, and then I said, and let me make sure I tell you, G. Yeah. Because F is, actually, G, what did I put? F. I put F. F is positive and decreasing on these intervals. And so that's what they're looking for. They're looking for you to literally say that you know that positive and decreasing equates to increasing and concave down. Believe it or not, that was only 2 points, 1 point for the interval, 1 point for the explanation. I thought C and D were easier than A and B, even though they were worth more points, weighted a little bit heavier, but I felt like they were more straightforward than the other ones. They didn't take quite as much contextual thinking as what the others did. The first one, C says the function h is defined by h of x equals. g of x over 5x, and it said find h prime of 3. This is nothing more than the derivative rules here with the chain rule embedded, the quotient rule, and everything else. So first thing I did was found the derivative. The derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared, which would be 25x squared. So remember in the beginning I told you right on that graph f equals g prime of x? That's literally just a point on your graph. So it says find h prime of 3. So that's the derivative of g at 3. This is on your graph. Look up at your graph. And then it's 3. What is y? -2. That's right. Times 5 times 3 minus g of 3 times 5. You already found g of 3. You found that in part A. Over 25 times 3 squared. Remember, this is not a calculator one, so I literally, once I plugged in, I stopped on this one because I didn't want to eat my time up or risk the chance of making a mistake. So I found g prime of 3, which I found to be -2. Look at the graph. At the point 3, what's the y? And now g of 3, you already found in part A. So that's 9. I left it just like this and I stopped. That would be fine. 2 points for the correct derivative, 1 point for the answer. Last one. Woo! The function p is defined by, this was a chain rule. It's funny how they take these easy rules and then they throw them in these hard problems like this. Find the slope of the line tangent to the graph of p where, so what are they asking for? They're just asking for this. That's literally all they are asking for. So first thing I did was found the derivative. This was another 3-pointer. I was surprised they gave us many points for this. So I did, this is chain, derivative of the outside, and then I multiply by the chain. You got 2 points for that. This gave you 2 points. Remember how I said write something, anything, take a derivative of something? I would give you 2 points out of 9 for just writing the derivative of that, which is crazy to me. You'd have to have the time on that. Sorry. All right, so this is f prime of, so -1 squared is 1 minus -1 times 2 times -1 minus 1. I do need to figure out what this is because even without a calculator, I need to. So derivative of f at 2 times -2 minus 1 is -3. This, remember, the graph is the derivative. So f prime of 2 right? The graph is f. That's right. The graph is f. So I need the derivative, which means the what? Slope. So this is the slope at 2. And the slope there, -2. That's exactly right. So 6 there. You got 2 points for the derivative, 1 point for the answer there. On the graph, yep, look at the graph.